All right. Hi, everyone. Hopefully you have drawn a triangle and cut it out and also made 3 copies of the same triangle. It's like I have them right over here. And you label them either as 1, 2, 3, or you label them as A, B, C, because I guess I did not follow my own instructions. Now arrange these in such a way that they stack and they look something like that. Okay. Now when you're arranging them like that, just be careful. For example, this is AB, so I rotate these. So my side AB is matched up with side AB. And similarly, my side AC is matched up with my side AC. Now what you notice here is that you get a straight line, right? You get a straight horizontal line. And the amazing thing is, no matter what triangle you started drawing, all of you would get the same result. As long as the stacking is done correctly, you would get a straight horizontal line. What this activity is actually showing is that in the triangle, the sum of 3 angles is always 180. Now that's a fact that you've already known, yeah. And this is a very quick way to verify it. You make 3 copies, and then if you look at this particular angle, right, when you stack them triangles, then you have B, and you have an A and a C, and you'll have angle A plus angle B plus angle C equals 180. Now once again, there are infinitely many possibilities of the combinations of these angles A, B, and C that add up to 180. Now, in the sort of interest of what we are doing here, which is working with simple objects, we're going to simplify this situation. And the simple objects, and then use that knowledge to focus on complex triangles. What we're going to say is at least one of the angle is exactly equal to 90 degrees. A bonus question here. I said at least, but actually it's also at most, meaning that a triangle can only have exactly one angle that is 90 degrees. It can have no angle 90 degrees, but it cannot have more than one. Now these triangles, which have one of their angles equal to 90 degrees, are given a special name called right triangles. And they are considered simpler objects because if you take any triangle, you can break it down into triangle 1 and triangle 2, each of which is a right triangle. So remember how we said any closed object made out of straight lines can be broken down into triangles? So we said, let's study triangles. And it turns out that any triangle can be broken down into smaller right angle triangles. So that's the simplest object under consideration. So we're going to study these right triangles. Now, it's a little magic of angles here. Recall, you need 2 lines to talk about angles and 3 lines to talk about triangles. So that if I take 2 lines and then I make these bunch of triangles by drawing right angles, right? These are all different triangles. So if I write their names, they are triangle ABC, triangle ADE, triangle AFG, and triangle AHI. So all different triangles. What's common to them is this angle. They all have angle A. The length of PC, length of DE, length of FH, and length of HI are all different. As you can see, they're all increasing. Similarly, AB, AD, AF. So these triangles don't have the same lengths of sides, but they share this one angle. Right? So what the conclusion we draw from this is that angle is independent of the length of the sides of the triangle, which makes sense. So there is no direct relationship between angle and length. Now this makes sense because remember, when did angles arise? Angles arose when you have 2 lines, right? So angle is a natural consequence of looking for a relationship between two sides or two lengths. Right? So it's natural to expect that if there is a relationship between angle and sides, then it's going to be between angles and two sides. The sides that create the angle. So these two or any other two sides. Now what are side lengths? They are just numbers. So again, in the interest of looking at really simple objects, if I have two lengths, the most simple relationship that I can consider is a ratio between them. What does that mean? Ratio between two numbers a and b. It's written as a is to b, and it's a rational number which is a over b. Okay, so what we have sort of reasoned out here is that because angle is independent of the side length, a possible candidate for the relationship between the angle and the sides is not the actual length of the sides, but the ratio of two sides. So this brings us to our next activity, which you can set up now so that I can talk about it in the next video. Draw any two lines. Okay, any arbitrary angle. Pick any 3 points on the horizontal line. Then using a ruler, draw out these lines vertically. And then what you're going to do is you're going to use a ruler to measure the length of the three sides of each triangle: AEB, AFC, and AGD. Okay, so do that, and then next video we're going to talk about more calculations that I'm going to ask you to do. That's it for this video.